So what we're going to do is, we've got 4 people who won the hackathon, and all 4 of them are going to speak, and we're super excited. They're going to do some little video and a presentation. So I'm going to introduce all 4, if you guys can give a wave. First, we have Nicole Tay. And then we have Phil Glasman. We have Alex Okalai. And Maddie Shang. Okay, Nicole, you all set?
Yes.
Okay, here we go.
Perfect. This is us. Oh, wait, hold on.
So I don't know, while she's doing that, I don't know if you guys know, it's a 24-hour hackathon. So it was really funny because Maddie said to me like, oh, I'm so, like, we almost had a Red Bull hangover. And I was like, okay, well, if you're gonna, Red Bull's the way to go. But anyway, so are you all set, Nicole?
Yes, we're good now.
Fantastic.
For real. All right. So, health research, while necessary, is inefficient and costly. Why? Because online data sets are not aggregated and they're not easily searchable. As many as 85% of medical research is redundant, costing us nearly $200 billion a year. In the case that you would want to obtain a specific data set, you would have to ask that scientist personally, which can be a bit awkward unless you are their colleague. And this is primarily because of the risks associated and the fact that scientist is not being compensated. The privacy and security of health data is also a huge ethical concern. However, if we can get over this barrier, as many as 80% of consumers are willing to share their health data for things like research. And lastly, there is a lack historically of participant control over their health information. Currently, participants enroll in a study and they contribute their health data for which they are paid. However, after that point, they're left completely in the dark as to any future use of that data. So, enter Mercantis. Mercantis offers a novel Ethereum-based solution with a React front end. So, after receiving the participant's consent, the source researcher can take their health data and upload it onto the blockchain. At which point, a buying researcher can purchase that de-identified data for a nominal fee that is given to the source researcher and the participant. So, for example, say Wendy enrolls in a diabetes study. She fills out a survey, and then she passes that along to the source researcher, who uploads it onto Mercantis as de-identified health data. The buying researcher can then obtain that health data for a fraction of the cost that it would have taken her to implement and design her own study. Okay, so I'm going to pass it along to Phil with a demo of our smart contract.
Thank you. I'm Phil. I'm going to show you how to submit research data onto this chain, how to query for it, and how to buy it. And I don't know how technical everyone is in this room, but I'm going to walk through it one by one very easily. So, in the beginning, here we have our smart contract, and we have 3 addresses. The first address is the researcher uploading the data. The second address is the participant, and the third address is the buyer. And so here, they all start out with 100 Ether, because we're using this on the Ethereum platform. So we're going to go ahead and submit data. What we're going to submit is, we're going to submit a VLOOKUP number, which for this case, pretending we're submitting blood pressure, the number is associated with 10 is the number associated with blood pressure. We're also going to upload the address of the participants, so they're properly credited an account once their data is bought. And we're also going to submit some metadata. We're going to submit that it's blood pressure and the price for it. So there we have it. We just submitted it to the chain, and now we're going to switch over to the buyer. Because we know that the data point is associated with the number 10, we can query for this number. And what we get back right here on the right side is the price of the data, which is 20, and metadata about the data. And we can go ahead and change it over to readable data, and here it is, blood pressure number 1, so we can confirm that this is the right data point we want to buy. And so now we can go ahead and purchase this data. We can query it for it, which is, again, we enter number 10, we enter the index number, which is 1, and we enter the price, which is 20. And as the researcher buyer, you're submitting 20 ethers to this contract address, and we can double check to make sure that everybody got the proper amount. And they did. So the first address is the original researcher that submitted the data to the chain. He got credited 90% of the price that he was selling the data for. And the second address, which is the participant in the research study, also got money for their own data. So in this whole process, the researcher makes money, and as well as the participant, which is the original health record. And you can check the third address, which is the buyer, and he was deducted the proper amount. All this data is securely stored on sort of like a hash table, double hash table, and it's easily queryable once you have a VLOOKUP number. And it's cost efficient and very fast compared to what we have today. So this was the back end portion. I'm gonna introduce Alex, which is he's gonna show you the more of the front end portion and how you interact with this data set.
Hi everyone, I'm Alex, and I will be showing the Mercantis front-end portal. Now keep in mind, this was made with Hackathon spirit, so it could be fleshed out a lot, but this illustrates the point. So if you get to the portal, different players for the system can be represented from their own UI, or they have their own piece of the portal. And click play. In this view, this represents the view for the source researcher. So this is the person who's trying to sell some data from a participant, or someone who's already sold, who's done their survey and given them health data. In this case, a source researcher is trying to submit the data for blood pressure data for a particular participant. The first view you see, or the first field, would be that of the ID of the participant on the blockchain. So this anonymizes, or it hides the identity of the participant, so you don't know who they are. It's anonymous data. So that's the first field. The second field is a ID that's specific to the type of data that the source researcher is uploading. So in this case, this is for blood pressure. So uploading this, everyone else will be able to query the data. The third field is a price that the source researcher will get from this. The fourth and fifth fields are those there's some metadata in the last field talking about the demographic of the patient or the participant. So I'm just going to go ahead and simulate a source researcher submitting the data. And it's going to play. But after the source researcher submits the data, you have a screen that represents being able to query the data. Now, if you have other people in the field, let's just say someone else is looking for blood pressure data. You put the particular ID for blood pressure, and you click search, and then you get a sample of data that's related to what you're looking for. In this case, there are two results that came back, and if you're someone looking for this kind of data, if you like what you see, you have the option to pay for that data, again, using the same ID. And then you get a link that's secure that you could download the entire data set from. The final view represents the view for the participant. So if you're someone who has taken a survey and you're willing to have your data shared, this is the amount of money that someone has made total from their data being viewed by different people. Now this is automatic. You don't have to. That's what the benefit of the blockchain is for this, actually, or one of the benefits. You log in as a user and you see, I have $250 today. This is all automatic. You're being compensated without, whereas previously, once you sell your data, you just don't even know. That's pretty much it. But in this case, you could. It's automatic from the blockchain. You're being paid, and everyone is being paid in an automated way. So that concludes my piece. I will pass it on to Maddie to close this out.
Cool. Cool, thanks Alex. I'm Maddie and I'll briefly talk about the future of Mercantis and the directions we might want to go into. So part of the reason that I was super excited to work on this prototype is because once I was doing some machine learning model training and I could not get any more better accuracy without getting more data. And it was incredibly hard to find good quality data to feed into my machine learning model, right? So this actually solves that exact pain point for a lot of machine learning researchers because now they have data, their models will be able to improve in accuracy and that will bring benefit either as a assistant to physicians to save them time or as a automated double check to make sure there were no like human errors or fat finger errors for scans and radiology and things like that. The second thing I want to talk about is extendability. While we decided to use medical research as a targeted use case because we have a medical research on the team and she knows the use case really well, once we prove this model to work for this particular subject area, it will actually be extendable to any kind of data set, decentralization, searching, and marketplace situation. And the last thing I want to talk about is the scalability of our solution. So the benefit of using the blockchain is that it will only cost us to upload each data point, and after that it will be immediately stored on the blockchain. It will not cost us any more money to keep it there, right? And then the beauty of that is, as let's say I'm one participant and I have like 2 pieces of data about me. As there are more studies done or more medical laboratory that was being produced that's associated to me, my data actually gets more valuable, which means our platform will become more valuable. But at the same time, our costs will remain relatively steady. And the other good thing about this solution is that because we're building this on the blockchain, we inherently get access to a lot of the cryptographic and security features which do not currently exist with a traditional system like AWS. So we're really proud to present to you what we hacked together in less than 24 hours. And yeah, thank you for your time.
Okay, well, thank you, each of you. These hackathons are amazing to me. I was a COBOL programmer back in the day, so it wasn't quite like that back then. Well, I know when I go to these events and there's hackathons and I see this group of people up there, I'm like, who are these people? So we've got just a couple minutes left. I'd love to know, Maddie, what do you do when you're not at a hackathon? I'm going to ask each of you the same question. Love to know your backgrounds.
I actually have a really weird background. I studied mathematics at University of Waterloo, and I also did a undergrad degree in finance, so it was math and finance degree at the same time. Naturally, I ended up in finance and did my CFA and all that, and ended up in venture capital. And then I got really bored really quickly, so I decided to go and work on my own startups. And from there, I realized that I had a technical deficiency, so I made a really hard bet to get good at technology, and that's what I did. So now I'm a blockchain developer, and I do a lot of machine learning-based model training as well. So that's pretty much me. In my free time, I fly airplanes.
Fly airplanes?
Yeah.
Oh, okay. Awesome. Nicole, what about yourself?
Yeah. Hi, I'm Nicole. I actually recently graduated from Columbia with my master's in public health, where I studied epidemiology and the social determinants of health. I really got into blockchain and health through just looking at health technology and doing research on it. So, most recently I did a study that is now, we're gearing up for publication on electronic medical records and electronic health predictive analytics among men who have sex with men. Yeah.
Thank you.
Or I had a fun fact.
Oh.
Hi,
Okay.
Alex again, and my history, previously I used to be in finance actually. I used to be a finance/economics guy, but I did that for a couple of years, KPMG, and I had a quarter-life crisis. I said, this is not for me long term. So I left, I'm looking around on YouTube and what else to do with myself professionally. And I found software engineering somehow. And I just quit my role at the time and I went back to school just abruptly, got a master's in software engineering, and then started professionally 3 years ago with Accenture. So I'm a software engineer by day. When I'm not at work, I'm trying to figure out other things, how to make it in life, and what else can I do on the side. I dabble with blockchain on my daytime role, and just other things. I rhyme. I just put words together sometimes. That's a fun outside of work thing.
Okay,
so,
thank you, Alex. And Phil, we'll wrap it up with you.
I'm Phil. I'm at university right now, and I study computer science. I'm a senior. I also work at Hyperbrands, which is an influencer marketing platform. I do analytics there. And I discovered blockchain from the economics perspective. Dealing with institutions, you have to trust them, and blockchain provides a really awesome way to create cooperating people in trustless environments, or environments where you can't necessarily trust every single party. And this hackathon really showed a new way how blockchain can enter the healthcare industry. What I like to do for fun is I like to read. I like to go on Reddit, and I cycle. So that's really my day-to-day.
Okay, well, we're just about out of time, but I wanted to, I don't know if everybody knows what the prize was. So these guys and women all came together, and thank you to the sponsors and Distributed Health. The prize was $10,000 in Bitcoin. Woo! So congratulations, and let's give a big hand for our team here.
All right, so as Susan said, Cab Morris run our kind of blockchain product development for the state of Illinois. One of the few kind of government, or at least U.S. government-based initiatives out there. So we'll be demoing a product we've been working on today related to provider identity management, and we've had great partners with Hashed Health in doing so. So let's get this pulled up here. All right. All right, there we go. So just a little bit on our background. So we're a consortium of 5 Illinois state agencies and 1 municipal level agency. I think it's really pretty unique that we've had quite a bit of buy-in from a lot of different entities in Illinois. As I said, I run our kind of product development, kind of our broader strategy. What do we want to do in this space? But you'll see up there, there's really a wide range of entities involved, anything from our municipal level recorder of deeds to the land registry agency, and also two regulators up there, the Department of Insurance and then our Department of Financial and Professional Regulation, which we'll be demoing, which the product will be a part of today. So, all right, so given the fact that this is distributed health, I'm not going to belabor this point. I'm sure we all know how big of a pain, provider identity management can be. I think there's a couple kind of interesting points that we've really tried to dig into. And as we started to talk through the use case with the team at Hashed Health, I think there were kind of a couple central points that we tried to really zone in on. One is that there's really not a great kind of coordinated effort to fix this out there. There's a lot of kind of interesting initiatives that I think are making some great progress, but what we found to really structurally fix provider identity management, I think it really actually has to come all the way back to what we're calling the gateway, which is the state licensing board. So the slide I showed you just earlier is our Department of Financial and Professional Regulation is our state level regulator. Our state medical board sits underneath their umbrella agency. So we really wanted to work through and kind of structurally address these issues. We think, it's really important to tackle it head on right from the start. So within that, though, we understood that, this is our first kind of real blockchain pilot that we're trying out here. We didn't want to get too far ahead of ourselves and tackle, a $1 billion problem right off the bat. So we really scoped this down to one pain point that we saw in the immediate or near term, which was, we'll get into a little bit later, but the question of how do medical providers move from state to state in a seamless manner. So if you are a licensed doctor in Illinois and you want to move to Colorado, how do you do that in an efficient way that doesn't take 6 months, which it does in some states currently? So within that, to give a little bit of context to a legislative initiative that's going on currently in many states, we're one of the founding members of, is the Interstate Medical Licensure Compact. It's basically a kind of a broad, almost kind of governance board that states sign enabling legislation to, and it improves the expediency of, or the expediency at which a medical professional can get licensed in another state. So basically, each time you apply for reciprocal license, the other state takes the primary source verification and all the documentation as good from the prior state, and you can fairly quickly, get licensed in another state. So what did we try to do here? So there's this kind of general governance body that has been set up to administer this, the Interstate Medical Licensure Compact. Their pain point has been, though, how do we sustain some sort of technology solution that facilitates this and the manner in which the policy tries to achieve fast. So we actually thought this was a really great opportunity to work through what we ended up setting up, which was really kind of a shared ledger system built on the Tendermint blockchain. So with that, you'll see here, so there's 22 participating states currently, and we really tried to use that as kind of the foundation for our kind of scaling of this out. So, hopefully 22 states could participate in this initially, but we wanted to make sure we designed this in a way that could be scalable up to 50. So why blockchain? Well, I think there's a couple kind of key points here, and this is something we always try to make sure that we really hone in on early on in the kind of our use case development process, which is blockchains don't fix everything. Let's fix something that actually makes sense for blockchain. So I think a couple key points here. First one being standardization. I think what was really interesting about this use case is that actually the data was standardized ahead of time, kind of by this enabling legislation. So it actually made the whole process of actually developing this product really pretty quick and efficient, which is usually not the case with these products. Programmability, this medical compact is supposed to help, improve the process or, increase efficiency of this kind of medical licensing process. If it takes longer using this solution, what is it really solved? So with that, though, we'll see in a little bit during the demo, we use some smart contracts to really automate the process in which states are actually inputting, reading and writing data to their actual kind of core system of records. Permission gradients, I think it's key. This is data that's chock full of PII. We want to be really careful and sensitive about that. And then really the last part, I think, which makes this a really nice use case is really the sync, or how synchronized. Blockchain's kind of a database, kind of a network, kind of both at the same time. And I think this actually gives us a really good view and gives the states that participate in this network a really good view of who's licensed, where they're licensed, and really up-to-date information on any disciplinary history at that point in time. So the basic process as to how this works currently, and then we'll kind of get into the demo a little bit more, is physician applies through the medical compact. There's a state sponsor that's called the State of Principal Licensure who verifies their eligibility. They submit that back to the medical licensure compact. The medical licensure compact then, after it's been approved, basically allows them to pick different states. At that point in time, they can go apply to whatever state they choose that's a member of the compact. So bit of a high-level overview there, but we'll get into a little bit more of the details when we actually kind of see how that interacts with the blockchain. So in terms of our kind of the system architecture we built here, like I said, it's kind of a shared ledger solution. So we envision each state to host a node, whether it's hosted in the cloud or on premise, really kind of up to them. But use that as kind of a kind of data fabric, a mesh that kind of bridges all these different disparate systems together. So like I said, we use the Tendermint blockchain, and we saw it as really kind of a nice lightweight way to do this. And as I said earlier, smart contracts writing data in and out of each state board system of record. All right, so in terms of how this actually functions on the blockchain, like I said earlier. So licensed physician wants to become a licensed Illinois physician wants to become licensed in New Hampshire. What is the process? So they would apply via the IMLC's website. From there, the IMLC is going to submit that to the state board, the state of principal licensure, as I said, so basically the sponsor state. State of principal licensure is going to basically check to make sure that they meet the certain eligibility criteria. And if they're eligible, they are going to write that data via smart contract to the blockchain. So the system of record was supposed to be centralized with the Interstate Medical Licensure Compact. That's what will be kind of the core data set. And also, as a part of that, the physician has also issued a letter of qualification. So from there, again, it's written back to the state's system of record, and then also the additional records are updated back in Illinois. So we keep track of where other physicians are licensed in other states. So you can see it's a pretty simple process overall, but we didn't try to kind of over blockchain it. We really made sure that it was lightweight and really achieved the purpose of, kind of a more efficient, more consistent shared source of truth. All right. So let's get into the actual demo video here. So wanted to make sure this was not just a PowerPoint, because I hate PowerPoints when we're talking about videos. All right, so we got to give hands out to the hash developers for putting this together. So on the left here, you can actually see the blocks as they propagate, and this is kind of the main part of the main kind of front page of the app. So you'll see at the top here, there's a bunch of different roles, and at least in this role here, we'll start as a provider, or logging in for the first step. From here, you can see kind of a basic overview of the process, and then underneath it, there's a few kind of key points to initiate the application process. Usually, an applicant would go in and authenticate themselves based off an NPI number or a state license number, and that would basically pull this core data set up from that state board. So you can see here there's quite a few different data points. There were a couple of them that we left out. We did not want to post people's actual Social Security numbers in the demo. So this is actually live data here from the state of Illinois. So with the initial application, there's a few questions that you have to answer here. Basically just attestations that you were a good doctor and intend to be one in the other state. And then at that point, you'll submit your application, and on the left here, you'll see the actual block get propagated. So yellow is just a block that's more recent than green, so no kind of functional difference between the two of those. But you'll see there, it's probably a bit hard to see, but block hash, block height, message, and then a timestamp as well. So it provides a perfect audit trail for all states to participate, or for all states that are participating. So log in as the state of Illinois, who has to approve this medical professional. So you can see there's a nice admin console, some basic information on the left side here. From there, you'll see that all the core data is available currently, and then this applicant is obviously pending review. So about 80% of licensed physicians are in fact eligible for this, and that have a state of principal licensure that's a member of the compact. So at this point in time, the processor on the Illinois Medical Board will be able to review this information here. Another prerequisite for this is that they pass a fingerprint criminal background check. And at that point in time, you'll see in the box below here, the state will receive that data and be able to attest that those prints were clean. So with that, also, the provider is currently eligible. So again, when we click approve here, we'll see that block propagate on the left side here. So at this point, they've applied for state of principal licensure. The state of principal licensure has issued this letter of qualification so that they can go and apply in whatever state they would like to. That's a part of the compact. So we'll log out of this here and then move on over to our other demo state, which was New Hampshire. So again, same kind of processing console. You'll see kind of the core information. Everything is all provided there. So like I said earlier, all kind of steps in this process are audible and are logged on this blockchain. So a couple kind of key components here. You'll see the core data set, and then when we open this up, you'll also see that the letter of qualification should be available. So that's encompassed in that provider eligibility report that we'll see here in just a second. So at this point, New Hampshire, all they have to do is click issue, and this physician is licensed in New Hampshire. I'm sure any doctors or any other licensed health professionals out in the audience probably didn't have this quick of an experience. Apologize for that. Sitting in government, it's scary sometimes how long it takes. But again, this step here is issued to the blockchain. So we're getting a perfect audit trail of all this. So we'll log out and just look at the one kind of last one or two views here. You'll be able to see that on this screen here, the last step in the process, that they have been successfully licensed in New Hampshire. If we scroll down a little bit more to the bottom, we'll see that they now have a New Hampshire license here. All right, so kind of one last little part that we'll take a look at here, and maybe if we're running a little short on time, we'll kind of wrap here. But this is really kind of, it seems pretty simple, but I think it's pretty powerful when you think of it in context of 20 to upwards of 50 states in the long run. So kind of wrapping this up here, I think, this was a really great, exercise with Hashed Health. They really did a great job of spinning this up. And, this is something that we see as production ready. And, we plan to hope to use this, with a bit more tweaking, not necessarily here in Illinois, but through the medical licensure compact. We want to really involve them in this process because we to see the power of this solution at national scale. So next steps, we've been doing a lot of other work around kind of architecting how we think identity should be tackled, at least from the public sector's perspective. We've been doing a lot of work with decentralized identifiers and verifiable claims, and I think that's kind of also an interesting exercise in the health identity or provider identity space. So this is kind of a bit of a concept that we're thinking through right now, but is also, I think, a really kind of interesting provider-centric way to think about managing data in healthcare. So that's it. We'll open that up to questions.
Well, first, let's give a round to Cab Morris. A round of applause to Cab Morris. Thank you, Cab.
Thank you very much, Distributed. This is an awesome venue. Let's give them a big hand. So I am extremely excited today to talk to you about what we're going to show, assuming the wireless holds up, because execution is everything, and we feel code, in some cases, is law. PokitDok is all about executing code for production, and what you're going to see today is actually going to be live running software development kit for DocChain. So to fill you in, and let's replay the events from this morning, Dr. Brian Smith gave a great synopsis and a shameless plug for yours truly. We have APIs, 4.3 million providers. State of Illinois, I had a good discussion with him. They could actually use that API. They use it for sole provenance of data. We have a complete CAQH level 4 clearinghouse. We have cash transparency for prices. We have 33 EMRs under one REST endpoint. We have identity proofing, validation, and verification. We have a complete PCI compliant payment backbone. We have the ability to compute the propensity to pay for the consumer in real time, and we can compute the ability for the provider to get paid from the payer. We have hundreds, close to 1,000 third-party applications built on top of our platform. And we have direct connections to over 600 payers. Some call them insurance companies, some call them trading partners, covering about 95% of the United States. We've been very busy because about a year and a half ago, we pulled a fork of Ethereum. We did the first production eligibility check. And then we moved to Intel Hyperledger Sawtooth because security is paramount. Scale is paramount. What you're actually going to see today is a software development kit that all of the entities in this room can use and outside, where we rolled up an Amazon machine image with Hyperledger Sawtooth, with IPFS or off-chain storage, actually running in the cloud on Amazon on Hyperledger Sawtooth. Okay? So what that means, and we've all talked about these scenarios, but it provides you an immutable, transparent picture of those validating the nodes in DocChain. It also provides the users, whether or not they're payers, providers, or the consumer, complete control. And then, obviously, because it's running in a secure enclave on a chip, it is completely secure. Even the code is signed in a permission blockchain, DocChain environment. So shall we continue? So we're actually running the application as a native iOS Swift application. We just generated the key out of the biometrics. If you saw that, that was Chris hitting the thumbprint. Next, for proof of identity, although we don't need to do this, we're actually showing some PII information, and it looks like the wireless is holding up very good right now, so thank you, Distributed. The zip code. And more security. So let me set up the scenario here. Mr. Wilhite, while he's the VP of front-end engineering, he's also an excellent guitar player. About a week ago, he was down here in Nashville, and he went out to the local watering hole, and he played a little too hard, and he had to have an MRI done. Okay. If he remembers his pass code. See, if we had key management running on DocChain, he wouldn't need that. There you go. Woo! All right. So remember this morning, Dr. Smith mentioned something about Social Security, stuff like that being non-consequential. We're going to demo identity by consensus, contextual relevant identity. What you do is who you are. This is not identity management in a match. This is a probabilistic model. If you go to a bar, you want to be anonymous, you want to be over 21, you want to have the ability to pay with a MasterCard. But if you want to show up at a provider with a weird infection on your leg, you want the immutable, transparent log to provide that information up to that point about any medical issuance in history. Very different scenarios, and we can compute this outside the realm of both health tech and fintech. We run across about 4 billion entities right now across multiple identity providers. So we verified Chris as the identity by consensus. We joined the DocChain network. So live right now, we're actually on the DocChain network. This is not some demo slideware stuff. We just joined it via the AMI. Hit continue. So now, I believe John Bass mentioned earlier about scanning a QR code. Well, lo and behold, what is that? That's a QR code. So here's what happened. He scanned in the asset, it generated a token. It generated a token for Chris's identity by consensus. It brought up the fact that he is now checking out because he played a little too hard in the bar the other night, and he had his MRI done in Jacksonville, Florida. Okay? We've done the identity by consensus. We've done a probability model on that. We generated the token. He's going to hit continue. And now what we're going to perform is autonomous auto adjudication, machine-to-machine rule execution for eligibility, and we're going to adjudicate the claim in real time. This is hitting all of our backbones. Remember I mentioned the fact we had APIs for all of those things? Now they're all smart contracts on Intel's Hyperledger Sawtooth. I want everybody to really understand what I'm saying right now. So, being the fact we're connected to all the payers, or most of them, the total cost is $810. BCBS pays, that's our provider, that pays $670, and Chris is going to pay $140. Now, we also have a PCI compliant payment backbone. In this case, because it's an iOS Swift native app, we better use Apple Pay. And so he's going to hit that, okay? And it's going to hit the Touch ID. Ding! Everybody hear the ding? So you literally, at the checkout, we just did identity by consensus and autonomous auto adjudication of that claim with rule sets on DocChain. It should be that elegant, and it should be that simple. And that was real code running in real time. Thank you. I'll be glad to take any questions.
Can you explain a little bit more about what you mean by identity by consensus?
Yes. Yes. So, yes, identity by consensus. Most people are familiar with identity match. I have one database, and is that Jane Doe? And everybody's been talking about the fact that provider identity is a subset of identity writ large, right? Which it is. Okay, so John Doe, the MD, could be an identity, but we also have Jane Doe, the consumer. Identity by consensus is the actual blockchain network, DocChain network, right? So you have multiple data providers that say that emit, I believe, Jane Doe to be based on behavior. And what the network does by consensus is vote on the probabilistic model of Jane Doe based on what she's doing at that time.
Meaning like she's getting her MRI?
Yes, or she's at a bar, she's 21, she wants to be anonymous and has the ability to pay with a MasterCard.
How many of them in this scenario, somebody's getting an MRI, who would vouch for that? How many people?
The question is, how many people would vouch for that? In this case, we can do 1 to N. It doesn't matter N. In this case, we hit 3 major, including ourselves, identity provider networks in that real-time process. So it is, for instance, we just hit, 2 of the providers just hit Interpol behind the scenes. Everybody heard of Interpol? Yeah, that's how serious this is. This is not like some sentiment analysis or some social network analysis. That really hit 3 different providers, including our own MDM. Does that make sense? But it could be 1 to N.
Hold on. Mike,
Still match your fingerprint. So there's still a match. There's still a match because it took the fingerprint.
Well, on his phone,
There's still a match with
it didn't use that information. It only used it for the phone access. It didn't use it for consensus by identity.
Okay,
Yeah.
so I have another question. Where are the nodes and what is the consensus?
Say it
You
one
can
more
answer
time.
that. Where are the nodes of the blockchains? And what is the consensus of the blockchain?
This is Intel's Sawtooth is Poet.
So that means that anyone can be a node as long as he buys the Intel chip?
Its permission is well, the Intel Sawtooth technology has already been shipping since 2016, but in this case, we're doing a permission chain.
Thank you.
What did the barcode represent?
Hey, John.
Hey, what does the barcode represent? So what is?
Oh, the QR code?
How do you reconcile what the barcode and the identity on the barcode to your identity through?
Because
Can
what we
everyone
did
hear the
was
question? Just want to make sure everyone can hear the question. Question was, how do you reconcile the barcode to the identity?
Yeah, in this case, it took it did the scan, and then we actually hit against the probabilistic model against the chain because just because he had the fingerprint, it doesn't necessarily mean it scanned that code at a given time.
So what is that represented on the barcode?
We actually the asset, yeah, like I said, the asset actually is a token on the doc chain.
Right, so it has to be a token on the doc.
Absolutely, yeah. I said the asset is the token on the doc chain.
Okay, so
Yes.
it's a pointer to your doc.
Yes.
And including the MRI?
Yes.
So it's all the assets, all the print.
Yeah, and I said IPFS stores the assets, the actual images off chain. Yep.
Hold on. Let's use the mic just so everyone can hear.
This is awesome.
I'm just a little confused on, so from the scan, the information for the MRI went to BCBS, to Blue Cross Blue Shield, to show how much they would pay prospectively?
Yeah, because
or is it actually happening in real time, the payment from the insurance company?
No, because PokitDok actually provides APIs for provider search, clearinghouse search, cash prices, identity, et cetera. We actually used our auto adjudication rule engine to match the cash price for that Jacksonville MRI at the time of service.
So they actually are putting in the actual procedure code?
Oh yeah, we actually have APIs for CPT and IDG as well. Down to the out-of-pocket cost, GeoZip, yes. Thank you. Say that again.
Hold on, another question, hold on.
Okay.
Can you talk about performance and scale, like
Yep.
in that process where they were being validated their identity? I mean, if there were 100 million patients, or, I mean, how does it scale as it grows? I mean, how big was?
Yeah,
how much data was there? How big was the network
just
in that demo?
We are looking at unoptimized about 1,000 transactions per second. per smart contract per node on the sawtooth chip. And they're obviously, you know, that's a Moore's Law issue from where it came from, right? Which is exactly, besides the security issue, is exactly why we did it. Now that it's computing the economics on the silicon, we can just keep going.
Got a question over here in the balcony.
Cheap seats. Hey, Ted. Scott Tuwicki with the Identity and Payments Association. It seems like the risk in this is in determining the probabilistic model and whatever algorithms you use. It seems like there is risk inherent in setting that up. How do you manage that? And is it some kind of consensus group approach to managing those probabilities?
That's exactly what it is, based on the consensus metrics of the blockchain network. So the multiple identity, because you got to figure, like, we've been in several basic identity shootouts, and I can assure you the accuracy hovers around, they get happy if it's 75%. In this scenario, we're operating at least 6 nines. Always. Who said that? Always.
Hey, how does it work with other payers? I saw Blue Cross.
I couldn't hear you.
How does it work with other payers? I saw Blue Cross up there, and you mentioned that you had.
Yeah, so we're connected to, if you want to validate and host a node, but we have BAA's direct connection with about 600 payers. But are you with a payer?
No.
Okay. But yeah, if a payer wants to host a node on blockchain, which we hope they do because they can have the provenance of the data and the adjudication rules, because all payers have slightly different adjudication mechanics. We hope they do. But let me say something. We always wanted PokitDok back in 2011 to be on distributed ledger technology. We had to get the momentum and the health industry saying APIs first. It's funny that APIs are now legacy. We turned into smart contracts. I could have put this on the blockchain back in 2011 when nobody knew about it.
Can a patient use this to access their own clinical data from the IPFS?
Can a patient, if somebody builds an application on top of this, to do so?
Okay.
Absolutely. That's what the software development kit's about.
Is anybody doing that, to your knowledge?
Excuse me?
Is anybody building an application to your knowledge?
Yes, we're moving to large-scale proof of values by the end of the year with production to, thank you. You can clap. Yeah. I think that's it. Thank you.
So I think we have time for one more question. And Bryce, do you want to see if anyone else has a question?
Back, you're going to make me run. All right.
Give him a run.
I don't run.
Let's give Chris Woolhite a big hand.
The question is, what is stored in the IPFS and how do you reconcile IPFS?
Say that one more.
The question is, what is stored in IPFS and how do you reconcile IPFS because it is immutable?
Yeah, so we actually we have an asynchronous process that synchronizes it to Hyperledger Sawtooth, and that's some of the mechanics we're actually doing on blockchain. The things like images, huge medical records, things like that, but the computational aspect is signed. We actually wrote an IPFS smart contract that synchronizes it across Sawtooth for the transactions.
Okay, so let's give a big hand to PokitDok. Thank you very much.